Okay, I know that we've kind of been solving some proofs already, but we're going to really get into the proof solving, proof writing process now. So we're going to start talking about segments and angles, and or some of these you already know about, like the angle or addition property, subtraction property, multiplication and division. We've talked about substitution. You guys know distributive. Reflexive is when you have the same thing equal to the same thing. This happens a lot when you have segments segments or rays that are shared by a side. And really, you just have to see the reflexive property in action to understand why it would be important. The symmetric property is if you need to flip something over. So let's say A equals B, and you wanted B equals A. Or if you had 12 equals X, and you wanted it to be X equals 12, that's technically the symmetric property. And then the transitive property sometimes gets confused with some other logic type things that we have. But I tell people with the transitive property, you go from A to B and then B to C, and then you can make the jump from A to C. And that's the transitive property. So if A equals B and B equals C, it looks like substitution, and that's another place people kind of get confused with that, but it isn't substitution. It's technically the transitive property to get from one to the other. Okay, the symmetric property is a repeat, and the transitive property is a repeat. So we have the segment addition postulate, which we've already talked about. I mentioned before that it works the same with the angle addition postulate. You can add two angles together to get a bigger angle. We've talked about angle bisector. We know what two congruent angles are. We know what two congruent segments are. Definition of midpoint, definition of perpendicular lines, right angle congruence theorem. So this one is a new one right here. Whoops. This one, right angle congruence theorem. If you have two right angles, you don't have to do the step where you prove that they're 90 degrees. You can automatically say they're congruent because they're both right angles. Okay, the next one is the congruent supplements theorem. If two angles are supplementary to the same angle, or congruent angles, then they are congruent. So let's draw some supplementary angles. Let's call this angle 1 and angle 2. So angle 1 and angle 2 are supplementary. Well, let's say that we also have angle 3 sitting over here. And I tell you that angle 3 is also supplementary to angle 1, then you can conclude that angle 2 is congruent to angle 3. Because let's say angle 1 is 100 degrees, that means 2 has to be 80. Well, if 1 is 100 degrees, then 3 also has to be 80 because they're both supplementary to it. So the congruent complements theorem works exactly the same way, except that together they equal 90 degrees. The linear pair postulate, two angles form a linear pair, then they are supplementary. Remember, that is not reversed though. Just because they are supplementary does not mean they are linear pairs. Vertical angle congruence theorem, we usually just say vertical angles are congruent, but remember what vertical angles are. And then we have the definition of complementary and the definition of supplementary. So we're just going to jump into some proofs and start practicing with these. So remember, all of these, we start with our table. And we have statements and reasons. And we always start with our given statement. B is between A and C, and that is given. And we want to prove that AC equals AB plus BC, But we know why we can do that. That's called the segment addition postulate. So sometimes proofs are just really, really short. Okay, OP bisects MON. So I'm going to go ahead and mark that. Oops. I don't know why it doesn't like to erase for me. Okay, bisects like that. Now we will have to have a statement indicating that that's true. Still an eraser. Okay. I spelled statements wrong, so I'm going to abbreviate reasons too. Okay, OP bisects angle MON. Well, bisect tells us that angle MOP is congruent to angle PON because of the definition of angle bisector. The angle bisector definition tells us that it cuts those both in half. Okay, so this one. M is the midpoint of AB. Find or prove that AM is congruent to MB. Okay, if you want, you can pause and see if you can do this one on your own, and then jump back in to see if you got it right. So we know the first reason is given. M is midpoint of AB. So hopefully if you paused and you did this, then you know you can jump right to AM is congruent to MB by definition of midpoint. Okay, so let's look at this next one. We have that AO is perpendicular to OC. So I'm going to go ahead and mark what we know, although we will have to do statements and reasons for that. So we know that line AO is perpendicular to line OC. And we know that angle AOC is a right angle by definition of perpendicular lines. And those are back on that very first page that we talked about. Okay, so here's another one. This one has some angle measures in there. Given that angle 1 and angle 2 are a linear pair, prove that they equal 180. Like I said, you can always pause, see if you can do these on your own, and then jump back in and check with me. Angle 1 and angle 2 are a linear pair. And so the measure of angle 1 plus the measure of angle 2 equals 180, not 3, is by definition of linear pair. Now I think technically linear pair says that they are supplementary. So if you wanted to say that measure of angle 1 and measure of angle 2 are supplementary, and then do step 3 that they equal 180 by definition of supplementary, that would be fine too. Okay, this one, A and B are complementary. We want to know that should be the measure of angle A plus the measure of angle B equals 90. Okay, so statements and reasons. Are complementary. So the measure of angle A plus the measure of angle B equals 90 degrees by definition of complementary angles. Probably don't even have to put angles on there. We can just say definition of complementary because it works for lines too. Okay, okay, so on this one, MN is congruent to OP, and OP is congruent to XY. And I didn't leave myself a whole lot of room, but that's okay. We can get there pretty quickly. So write your given. Okay, we've got some wild lines happening there. Oh dear. And OP is congruent to XY. I guess it doesn't like me writing tiny. Okay, so we had that property where you said if one is congruent or equal to another, and that same thing is congruent or equal to another, then you can just say the first is congruent to the last. Now, if you want to challenge, pause, go back in your notes and see what it's called, because I'm going to go ahead and write it down. It was the transitive property. Okay, so this one says if the measure of angle A equals the measure of angle B, then we actually don't want the measure on there. We want to say that angle B is congruent to angle A. Okay, so measure angle A equal to the measure of angle B. And we can say if the measures are equal, the angles are congruent by definition of congruence. And I do sometimes just abbreviate that. Okay, let's see what we have here. The measure of angle 1 is 72 degrees. Angle 1 plus angle 2, I think that's supposed to be 180. I think we have a typo here. Maybe not. Let's just roll with it. We'll see what happens. Okay, so statements, reasons. The measure of angle 1 is 72 degrees. The measure of angle 1 plus the measure of angle 2 equals 108 degrees. We just want to prove that the measure of 72 plus the measure of angle 2 equals 108. So all we had to do was substitute. So remember, do not abbreviate substitution property. because it looks like subtraction. Okay, ABC is congruent to DEF. We want to prove that their measures are equal. Well, we just did one like this in reverse. So like I said, if you want to pause, see if you can answer this on your own. ABC equal to angle DEF. So the measure of angle ABC is congruent to the measure of angle DEF by definition of congruence. Remember I told you earlier that congruence can go either way. It can go from equal to congruent or from congruent to equal. Okay, and I think this is our last one. It says given that angles 3 and 4 are supplementary, prove that the measure of angle 3 plus the measure of angle 4 equals 180. Okay, so we know the first reason is given. That angle 3 and angle 4, that's an angle sign, are, and I use SUPPL for supplementary. The measure of angle 3 plus the measure of angle 4 equals 180 degrees. That is by definition of supplementary. So these have just been really short 2 or 3 step proofs. I think they've all been 2-step proofs to kind of get you used to using the statements and the reasons. So I now want you to go onto Google Classroom, and there are some proofs on there that are drag and drop proofs, and you can practice putting them in order, seeing if you get them right.